So write those three ordered pairs down, 4.3 modeling with quadratic functions, and we are going to develop kind of a weird-looking XY table to deal with this problem. So the difference in the XY table is as follows. So you do the order pair at the beginning. Standard form of a quadratic goes in the middle. You put the equals y at the end. And then the third column is going to be a matrix, not a matrix. So on the left here, we get the order pairs. And then I'm just going to write the first one and I'll let you get caught up. So what are we doing here? What's happening? I'll babble as you guys write this stuff down. We have an x and a y value in each of those order pairs, right? So what are we doing? We're taking this x value here and plugging it in for this x. We're taking the x value and we're plugging it in for that x. Okay? The y value goes right here and then gets repeated right there. Question, Delia.
Why did you get the 1?
I got the 1 because the coefficient in front of this c is a 1, so that's where that 1 came from. Okay? So you might have the question, will the 1 repeat? Always. You'll have 1, 1, 1 as that third column. So you can just fill it in right away if you want. That's total legal math move.
So it'll always be 1?
It will always be 1. It's rare when I can say always, so I would like when I can. So filling in the next one, right? You're filling it in for x. We're use this matrix to determine A, B, and C. That's the information we're getting. Okay? So when we plug in, you're only plugging in for x. If you don't use parentheses, I will take off like 10 times worth of points in the problem. Is that unfair? Yes, it is. I don't care. Complain, please. So just filling in that second one, right? I'm just plugging in -1 for x. So I'm thinking to myself, what is -1 squared? Well, -1 times -1 is +1. So I'm writing that down. -1 times b is -1b. So what is the coefficient on b? The coefficient on b is -1. So again, I'm squaring -1. That's how I got a +1 right here. Then I take the -1 times b, it's still -1. That's why I wrote a -1 in the middle. And then we'll do the last. The thing students forget most is to square that first term, and then it goes horribly wrong. So the last one is going to be 1, 1, 1, and then the 3 by 1 is going to be a 6. I forgot to write the -2 in the middle here. Where the highlights key, right? You go back and look at your notes. I guarantee you'll forget how to do this by the end of the lesson. You think I'm ridiculous for saying that? You know I'm not. So if you do the highlight, it's like, where the hell did I put that at? Oh yeah, it's like the x in right here for the x's in standard form of a quadratic, and then it just makes more sense. So bust out the calculator. We're going to do second, x to the -1. 1, negative 1, 1, and 1, 1, 1. I already have it in from the last period, but actually I'm going to just reset my calculator, so I have to do it again. So I did second x to the negative 1 over to edit, and then I want a 3 by 3 matrix. So I've got 1, there's 0, 0, 1, and we're doing something wrong already. Second one is 1, negative 1, 1. Third one is 1, 1, 1. So you want that 3 by 3 matrix, and let me know if you need help. If you're getting confuzzled, I'm more than happy to help. What's up, Trevor? This one I'm on here. Second, right up top there, you can tell because the button turns red, x to the negative 1. And then I right arrow up top, so I'm on edit right here. You good? Okay. So I got my 3 by 3 in. Now we're going to go second, x to the negative 1, over the edit, down to the b, and enter in a 3 by 1. So second, x to the negative 1, over the edit, down to b. If you get concerned about having 3 by 3 matrices in other areas in your calculator, you can reset it and it'll be gone. So we want 0, negative 2, and 6. One sec, I get you. 0, why are you doing this? 0. Okay, question. It doesn't matter. Yeah. You will just, when you get in the main thing, you'll be C first, not A. Okay, we good? Give me a thumbs up if you're ready to hum. Excellent. Okay. Back to the home screen. That's the thing I always forgot. You get back to the home screen by hitting second mode, second click. Then we hit second, x to the negative 1. You want to enter your 3 by 3. I'm in the name screen right now. That's the key. I hit enter, then I hit my inverse button, just x to the negative 1. So it looks like an exponent of negative 1 on the A matrix. Then we go second, x to the negative 1 again, down to the B, and enter twice. Questions?
I did something wrong.
So what happened?
Negative 1.
I got the negative 1. I'll just clear it out and do it again. So we go second, x to the negative 1, enter, and then I just hit the x to the negative 1 button.
Okay.
And then second, x to the negative 1, down to b, and then enter twice.
Yeah, I'm not getting what you got.
Okay. So that just means you have something in the matrix strong, so hit stat, or no, second, x to the negative 1, over to edit.
Oh, why is that negative 5? That's the problem.
Now you got it. So if you fix that, you should get, so we got 2, so it goes in order, A, B, C, top to bottom. So we got 2, 4, are you good? Sweet. You can take your line racing down. So it looks like this, right? Our answer, 2, 4, and 0. So the A from standard form is 2. The B from standard form is 4. The C from standard form is 0. So you must write the equation now. So we have to write 2x squared plus 4x. You don't have to technically write the plus 0, but I won't take points off. So what is our answer? Our answer is this. If this problem's worth 4 and all you give me is 2, 4, and 0 like this, I'll take off, I don't know, some punishing, like at least half the point. Just write the equation, right? Yeah.
Do not write down the y equals or equals.
You can put equals y if you want. You can put y equals. Yeah, that's fine. I don't really care. What I care more about is you having the equation. Okay, so why the hell did we just do this? This is a totally valid question, right? So I have 3 order pairs here, 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 and here. This parabola will go through those 3 order pairs. So we just did calculations by hand to figure out the exact equation of the parabola that will best go through these 3 order pairs. This is one way to accomplish that task. Okay, we're going to do a totally different way in a bit here. I think it's like the second example. Yeah, not this example, the one after, we're going to do a totally different way, same process. Okay, take it back, read this one. Don't write anything down, just read it. Try to understand everything you can. Look at the picture, understand, think about the A value when you look at the picture, think about the height of the rocket. Is the graph talking about rocket 1 or rocket 2? Is the equation talking about rocket 1, rocket 2? All things you need to decipher to do this problem correctly. Okay, I will not read it, so we're comparing quadratic models. So that means we have 2 different quadratic models. So we'll say quadratic models and instantly like 40% of you freak out. Just a quadratic equation, right? We've been graphing them in a number of different ways. No need for stress. Of course, some of you will stress regardless, but that's your own personal issue. So rocket 2 is this graph right up there. Rocket 1 is the equation. Okay. So campers at an aerospace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by the equation h equals negative 16t squared plus 150t plus 1. Where t is the time in seconds, h is the distance from the ground. The path of rocket 2 is modeled by the graph X, right? Which rocket flew higher? So how many people understood it better after I read it? Raise your hand if you did. Okay, we have somebody in person still completely lost. Oh my God, I have no idea what's going on. Don't be like that. So the reason I asked you how many people understood it better when I read it is because I want you to think about that, right? So you can sound like the crazy kid in class if you're taking a quiz and like softly read it out loud to yourself because it'll make more sense. Just you hearing the words will have it make more sense in your head. Okay, so when we look at this first equation here, we can tell that it's got that negative 16t squared. Anytime you see that negative 16t squared, we're talking about gravity, right? If you throw a ball and it's going to eventually hit the ground, that's the gravity. That negative 16t squared turns that parabola upside down and will help it to hit the ground. So we want to know which rocket flew higher. Key to understand that last question, and then we'll also talk about, on the next slide, it talks about finding domain and range. So we'll talk about domain and range for these things. And that's good for now. First thing we're going to do is the green highlighted, blue underlined equation. We're going to get the max for that. So we're going to plug that into the y equals of the graphing calculator. So we're going to hit y equals. Make sure your plot's off. You only need your plots on when we enter data. We are going to do one where we enter data later, but you don't need it for now. So negative 16, don't do t, the calculator doesn't understand t. You have to replace that with x. Don't forget the plus 1, it's easy to forget that. 1, what part of the parabola is the plus 1? Oh, I'm making you remember something all the way from last week. I know it's a challenge. What part of it is plus 1? The y what? Makes me want to murder you all. I don't want to go to jail. Y-intercept. Thank you, Henry. It is the y-intercept. So is it good? Thank you, Amanda. So the 1 foot represents like that rocket launcher, right? It's not going to fit right on the ground. It's got to be a little above the ground because it flames out of the bottom and it'll catch all whatever on fire that's underneath it. So the 1 is like 1 foot off the ground for the rocket launcher. Okay? We know, looking at this thing, the other one had a height of 580. So I'm going to assume, right, rocket 2 has a height of 580. So I'm going to assume rocket 1 is at least around that when I change my window. Right? Because if I hit graph, it's not going to show up right now. So I'm going to click window. I'm going to change my Y max to 600, bigger than the other max. So go down to Y max. I'm not going to change anything else. You can see over here what my graph looked like before I made any adjustments. It basically looks like 2 straight lines. You know that's not what it looks like because it's squared and it's negative, so it's an upside down parabola. When I change my Y max to 600, this is what it looks like. Which rocket flew higher? You should be able to tell right now. 1 or 2? Second one, right? Because the second one went 580. The top of my graph here is 600. That's not even close to 580, right? It's like a little more than halfway up, so I guess around like 400-ish, maybe a little less. Think along those lines because it'll help you. We're going to get the maximum value by doing second trace, maximum, option 4. Remember, you can just type 4. So I just want to emphasize this again because I guarantee some of you will find this issue. You think to myself, oh my God, my cursor's gone. Where the hell is my cursor? I have no idea. So I know x equals 0 right here. My cursor value is -3. If I want to see my cursor, if I hit the right arrow, my x values are increasing. Now it's -2 and change. Still -2 and change, but getting closer. Now it's -1 and change, so I'm getting close. I should see the cursor any second. Watching these x values right here, right? Once it hits 0, I should be able to see that cursor. Because that'll happen to you guys, and that's like a serious moment of panic during a quiz. If you can't even find your cursor, you're like, how the hell am I supposed to do the problem? So, roughly the same height on both sides. And the height of this thing is, we'll say 4.69, 352.56. 4.69. 352.56. Okay, so this is, the 4.69 is the time. Seconds, it takes that rocket to reach the top, the apex of the curve, the top of the curve. Sheila, did you have another question, or did you just forget to take your hand raising down? Okay, no worries.
That was an accident.
That's all good, no problem. So 352 is the height, the max height that rocket 1 went. So height in feet. The question is, which one went higher? Rocket 2 went higher. Rocket 2 went 580 up in the air. Rocket 1 only went 352. So rocket 2 went higher. So which rocket flew higher? Rocket 2. I, of course, will make you tell me how much higher, so you may as well just write it. Rocket rocket 2 at 580 feet high. Max height of rocket 1 is 352. So if I give you a problem like this on your quiz, I'll say height rocket 1, height rocket 2, time rocket 1, time rocket 2, which one's higher, how long did it take to get to the top, how long did it take to hit the ground. So looking at rocket 2, how long did it take to reach the max height?
6 seconds.
How long did it take to hit the ground? 12 seconds. Right? So that's 6. From here to here is the first 6. From here to here is the second 6. So how long did it take to hit the ground? 12 seconds. So just realize that. Multiply the x value by 2. Exactly. Multiply the time by 2. Okay? So now we're going to talk about domain. I'm just talking about rocket 2 for now. Okay? So let's define that so you understand. You got rocket 2. Rocket 2 goes like this. Over here is the 12. In the middle is the 6. This point is 6, 580. Okay, so we need to talk about domain for this rocket 2. I'm only going to do it for rocket 2 because the same stuff applies for rocket 1. So domain is the x values, right? If you forgot that, maybe you write a little x right next to it. Range is y values. So where do my x values start? What's that point right there as far as x? 0. So my domain values start at 0. They end at 12. So that's how you write a compound inequality. That means in between 0 and 12. It's always, for domain, x in the middle. It's always less than or equal to. Small number on the left, big number on the right. That's how you write in between. See if you can write the same compound inequality for range. You can do it. Don't laugh. Don't you? You're laughing at yourself. Which you should laugh at yourself. That's good. I laugh a lot at myself. I love how my Rubik thing just shows a blank screen. It doesn't show me walking around at all. Pretty helpful. Okay, so if we're talking about domain, right, we went from 0 to 12. So I took this 0 at the beginning, I took the 12 at the end. Domain is x, the x in the middle, it's always less than or equal to. So if I do range, I start at 0 again, it goes up to, I don't know what I wrote this, 580. Right, so I'm following the same exact pattern in writing the range. 0 on the left, 580 on the right. This time it's a y in the middle. So 0 less than or equal to y, less than or equal to 580. And we know that 0 should technically be a 1, right? Because the rocket launcher is 1 foot off the ground. The book doesn't even get to that level of specificity. And I'm not, if I taught advanced, I'd be a total pain in the ass about that thing. Just getting the concept right here, being able to write that compound inequality correctly is important. Amanda and then Lee?
Is that always moving zero?
For this kind of problem, yeah. Because it's got to start from somewhere, right? Like if I were throwing a baseball, right, I throw it here, my hand, I'm 5'6", my hand is maybe 6 feet in the air, so we would have the +6 6 right here, and this 6, so how long does it take to hit the ground? 12 seconds. Okay? Perfect questions to ask, because I guarantee that cleared up some stuff for other people as well. Any other questions?
So it's like total time as well.
Total time.
Height is fine.
If I ask you, like, how long did it take to reach max height, that's 6.
Okay.
If I say how long the total path of the rocket from launch to ground, that's the 12. Okay. Yep. Okay. Break this chart down. Next problem. Now we're doing a quadratic redirection by hand. Okay? Quadratic redirection by hand. You're going to love it. It's going to be so awesome. Yeah.
Where I would ever use
I know. Exactly what all of the in-person people were thinking. Their love for quadratic redirection. No, don't do that. I get kids in regular Algebra 1 that want to sign up for advanced Algebra 2 or whatever. I'm like, why? Why would you do that to yourself? The bonus about regular class versus advanced class is we really get to teach you. In a regular class, advanced class, it's both instruction plus you discovering the concepts, and that's where some people that struggle with math get wrecked. For me, I'd rather just be taught so I can demonstrate what I've been taught. I find that easier. But that's just me. Okay, so you know with the x's, weird crap always happens, right? We did linear regressions. They start at like 140 or 1940, and we change that to 0. 1950 would be 10. 1960 would be 20. So we're always messing with those x values. This problem is no exception because we can't go 8, 10, 12, 2, 4, 6. It doesn't make sense, right? So we got to go military time on the 2, 4, 6. So this would be like 1,400 hours, 1,600 hours, 1,800 hours. Actually, speaking of military time, just had a former student reach out on Facebook who's in the military. So I'm super curious to hear what he has to say. Haven't had a chance to check yet.
That's a fun military time.
Hardcore. Okay. So we got the chart, right? X values, 8, 10, 12, 14, 16, 18. We're going to put in the Y values, L1, L2. Just waiting for a couple of people to finish writing the chart down. And then we're going to enter them into the graphing calculator. To remind you, you hit stat next to the left arrow, and then edit, which so basically stat enter. Edit is already on edit once you hit stat. And I'll show you on here. Go back to the home screen. I'm going to clear that out. I hit stat by left arrow, enter, and I want to enter 8, 10, 12, 14. Oh yeah, somebody did it for you. You're lucky. 18. If you have crap in your list, remember you go up to L2. You hit clear. And then you arrow back down. It'll clear your list. So 8, 10, 12, 14, 16, 18. 8, 10, 12, 14. So now I'm going to enter the right column. And I always double check the crap out of everything because I get irritated if I get it wrong. So that's what it should look like in the stat edit. Again, the only difference between those initial calculator directions I gave you and this one is this very next step. So you can use those first calculator directions. I'm telling you right now, I'm not redoing them because it's stupid. So we're going to go stat, right arrow up top here to calc, and instead of doing number 4, linear regression, all we do is number 5, we're doing a quadratic regression. So you can arrow down or just hit 5. You know you hit the right thing because you can see it right up top here. It says quadratic regression. So you want to make sure you have L1 for X-list, L2 for Y-list. Anybody need help? Yeah, good stopping place. Oh yeah, so you got the funky one. Let me just, I'll come back to you in just one sec, Delia. So the rest of you that have this screen, go down to store regression. You want to click bars, right below the down arrow, right arrow to Y bars, and then you hit enter a bunch of times, 4 times technically. So enter gets you to the Y1, that's what you want. Enter, time to calculate, enter again, and there's your equation. Okay, for you, Delia, yours looks like this, without the L1, L2 fun. Deleted the wrong thing. Let's try that one more time. It's going to do it in a minute. Like you have second, number 1, comma is above 7, second, number 2, comma above 7, and then to the bars, Y bars thing. So bars by the down arrow, right arrow to Y bars, function enter, Y1 enter, and then enter. Okay, so this is our equation we want. Screen capture thing disappeared somehow, I don't know why. Not many. I know, I can tell. Let me just gotta fix this one thing that's going to annoy the crap out of me. Equation. If you write it like this, I get so annoyed I can't even begin to tell you. This, when you write this down as your answer, that tells me you have no idea what's going on. It's not no idea, that's me being a little harsh, but, you know, I like to be harsh. So negative, I'm going to round to 100. 0.47 x squared. You must write it in standard form for a quadratic. Okay, so plus 14.72. You don't know how to round, please ask so I can help you learn how to round. It should be a little embarrassing, honestly, if you don't know how to round. But I had this one student, one of my all-time favorites, great young man, he just could not round, like it did not compute. Well, I tried to help them every way I could. We have other, it was like a running joke. We had like everybody trying to help them round, and he would get it, and then we'd ask him another question, like 5 minutes later, he had no idea how to round again. Like full-on A students, just like mental block around rounding. So it happens. Hopefully not to you. There's our equation, okay? So because of, many of you guys could see the correlation. I reset my calculator so I have to turn on my correlation again. Give me 1 sec to do that. Super fast calculator. Keep going now. That's pretty good. So if I put that equation back in, now it'll show me that correlation R squared. Like Mr. Grace next door explained to me the difference between R and R squared. I honestly couldn't understand what he was talking about, so I have no idea. It's correlation, okay? It's just slightly different. He honestly didn't explain it that well. It's just a weird technical thing. We're going to talk about the correlation because the reason we talk about the correlation is because it tells us how accurate the predictions can be. Okay, I want to get to the graphing portion of this program. It's going to be okay, calm yourself. So we're talking about time and temperature. I want to be able to see the dots in the graph. Okay, so here's what we're going to do. We're going to change our window. So our x values on this problem went from 8 to 18. So I'm going to change my x min and max to 5 and 20. I could have chosen 0 and 25. I could have chosen 7 and 19. Like, all of that makes sense. So don't be mental about the window. I know you all are. Yeah.
I didn't know how to do
Because it says x min and x max. Because the first column is x, second column is y, right? Okay. Again, it's good to ask those questions, right? That's a little confusion, unnecessary, but confusion nonetheless. Smallest y value is 52. Biggest y value is 81. So I just got to go smaller than 52, bigger than 81. So I'm going to go 50 and 85. I could have gone 51 and 82, right? I could have gone 25 and 100 if I wanted. So then you'll see your beautiful little parabola. Mine got cut off a little, so what I would do is just increase my x max so I can see the whole thing. Let's just go 30. I'm not going to go incremental and go 25. Because that just irritates me. So, I just like seeing the whole parabola, Henry. You just calm yourself, right? Henry's like, isn't 30 a moot point because there's only 24 hours of the day? He's going a little too technical for us here in regular algebra 2. It's all good, Henry. I like the thought process. So if we want to see the little dots, right, we got to turn on our plots. You do that by hitting the second y equals. You can see my plot 1 is off. So I'm going to hit enter to get in there. Off is highlighted. I hit enter, so on is highlighted. And then I can hit graph, and I'll see the dots and the parabola.
Can I change the colors on mine?
You can change the colors to any little thing you want.
What? How did you get the colors?
Your calculator tool, sorry.
No, I know that. How did you get the colors? What's right?
Second y equals. Make plot 1 on.
Whoa!
So if I go in there, if you've got the color calculator and you want to change your little dot colors, you just go there and you can change them to anything you want.
No, I didn't.
question, wasn't it? It was like gray, light gray, brown. It looks like orange.
I calculated it. You have to say it was mine. Look at the desktop.
Look at the
It's
really
matching.
obnoxious color.
Woo! I'm sorry. You're way too excited. It's so cute.
So it almost fits exactly all of those ordered pairs, so it's pretty cool that it'll do that, right? So that's what your parabola looks like. Let's go back, because it seems like we did this question about 12 hours ago, and see if we answered the question. There is no question. Let me look at the textbook to see what the question was. I think I missed copying the question. Let me just see here. The question was, what's the quadratic model? So we wrote that down. All right. We want to predict the high temperature for the day. So we're going to do what? Second trace what? Maximum. So if I say second trace what, and you're like, I have no idea, do second trace and then you'll know. Because you're all smart people. Well, most people. Now you're wondering, do I think not smart, right? I would never tell you.
Definitely.
Definitely all the people in this room right now. No, just kidding. So there's our max, right? Hour 15. What hour of the day is that? 3 p.m. and change. Almost 4, right? 3:40-ish. It'll be 79 degrees outside. 3:40, it'll be 79. So I'm just going to copy this little graph.
How do you get 4? How do you get
1500 is 3 o'clock. It's 0.69 after 3 o'clock. Of course, it's got to be 0.69 as being a high school class, right? 0.69 after 3, so 70% of the way towards 4. So what is 70%? How many minutes is 70%? You want to know exactly? This is how math teachers think. You're like, no, I don't, Mr. Evans. You guys are not going to. We'll do it times 0.69 for good measure as well. 60 minutes times 0.69, it was 3:41. At 3:41 p.m., it'll be 79 degrees. You don't have to do that, but 3:41 p.m., 79 degrees. Okay? It's not that hard to take 0.69 times 60, right? 60 minutes in an hour. And then you can figure it out, it's 41 minutes past. By simply doing this calculation, right? I'm going to copy this over here. So the 41 minutes came from doing this calculation right here. Okay? So all of you can do that calculation. You should write that down, because if I tell you to write it down, it means you're probably going to see something like it again. So, make sure. All missing 2, Monday at midnight, 6 days from now. If you didn't write that down yet, write it down. My favorite thing ever is when you try to turn it in on Tuesday, because I get to get creative in my snack talk. Okay? And I will write that. I don't care at all. Like, if I write something and you complain to your parents, bring it on. I love it. It feeds me. Okay? So, quarter/semester 1 of Algebra 2 is over next Friday. Not this Friday, but next Friday. Your grade is posted. Whatever your grade is is next Friday at 4 p.m. will be your grade, because I'll have everything in that will be your grade for semester 1 of Algebra 2. That goes on your transcript. So next week, your grade resets. You all start over. Okay, fresh start in Algebra 2. So if you tanked first semester, you can get your act together and go from like a D semester 1 to an A semester 2. You have that possibility. Okay, if you already have an A, continue what you're doing, continue to kick ass, and you'll still have an A next semester. Okay? So your homework is right here. Your homework is problem 7, 9, 11, 16, and 17. This is page 212. So your homework is 7, 9, 11, 16, and 17. Okay, bust a move on that. We'll talk about 16 in greater depth. It's just like the rocket problem we did, where you're getting the mass of this equation and this right here. You're doing a quadratic regression. You're getting the height of both. Just like we did. If you want to do this one first, because that stuff is fresh in your mind, do it first. Right? The moral of the story here, will each all pass through the hoop? The answer is yes. We'll talk about why that is later. It's not worth talking about right now. Okay, bust a move on that. 7, 9, and 11 are like that first example we did. And you're filling out that chart, right, and doing the matrix. That's 7, 9, and 11. Okay? Don't forget to square that A term. That's the key. Any questions about what we did today? Trevor.
With that math lesson, I got all the formulas.
Okay.
My mind is right now.
You hit y equals? Take that equation out. That's the previous equation. The reason you got that, you didn't get the equation, hit stack out 5 and show me the graph again. So show me what your screen does. Back to the home screen, stack out 5, pull it back just a little and up higher. Higher. Move it in. Okay, go down to store regression equation. And that's where you want to do the bars, y bars, and then enter 4 times. That's what you forgot is to store it. That's why you couldn't see the graph.